Hi, how's it going? We are slowly getting closer, ever closer to drawing something on the screen. In this video, there are two things we need to do. First of all, we need to set up frame buffers. Now remember, a frame buffer is pretty much a structure for attaching various things. In common cases, it's, color, depth, and stencil. In our case, just the color buffer. Those color buffers already exist, but we need to attach them. Then we have something called a command pool and command buffers. So here's the deal. In Vulkan, everything is multi-threaded, and one of the benefits of that is you get multi-threads, but one of the responsibilities of that power is you need to break things down and specify each of the kind of sub-steps in a command. So we can't just straight up say, hey, draw something. We need to say, okay, this is the procedure used for drawing, and those procedures are stored in what's called a command buffer. Think list. When you see buffer here, think like a list of commands. And then those command buffers, those lists of commands, are allocated to a command pool, and then the pool, like they're swimming around in the pool, and those command lists are picked up and sent to threads and executed. So it's a slightly different way of thinking about things, and this is the first time we're seeing it, but later on when we start moving memory around, then we'll be using a similar kind of command pool, command buffer structure for that. Okay, so in this video we're not going to be drawing things. We're not there yet, but it'll be this and then one more video and then we'll be drawing things. So I'm going to try to bang it out as quickly as possible. Okay, let's create the frame buffers. So by the way, this is how it goes. We've created the graphics pipeline, then we create the frame buffers, and then the command pool, and then command buffers. Think about things like three. Okay, so we could have two images, one to draw to, one to present. However, because our system is multi-threaded, we could be drawing and presenting at the same time and have CPU power, graphics card power, which isn't being used. So for that reason, we'll just add one more and say we have a triple buffer system. Okay, well, each of those three images needs to have a frame buffer associated with them. So what we do is we set the number of frame buffers to the number of image views that we have. Okay. Then we go through this, we declare the image view as an attachment, and we declare this frame buffer. It is associated with our main render pass. It has one attachment, and yeah, you can see how this goes. We create that, and there we are. We've created all of our three, in this example, frame buffers. Then we'll go to the command pool. Now the command pool is a very simple kind of structure because, well, I mean, a pool, what is it? It's just cement and water, right? So the important thing is that a command pool, single command pool, can only be associated with one sort of queue family. In this case, this is a command pool for drawing commands. So we find the index of our graphics, our family, and set that for the pool. Okay, then we need to create the command buffer. Now, what each command buffer or each command list is going to do is perform a render pass, so draw the thing, basically. And the way we specify that is we do like a trial run. So we specify each of the commands which are involved in drawing. And yeah, let's have a look through it. So first of all, again, we have three frame buffers, so we're going to need a command to draw each of them individually. We create the command buffer, and then the next step is we need to record the commands for the command buffer. So we step through here, and we begin the command buffer. So what that does is it begins recording. See down the bottom here, we end the command buffer, that ends recording. And then this structure inside is pretty much specifying the render pass that we want to be performed. So yeah, we're going to begin a render pass. It's associated with our frame buffer that we're looking at within this loop. We have these bits here, clear color, render area, all that sort of stuff should look okay. So we execute a command to begin the render pass. And this one here, contents inline. If you think about C++, when you inline a function, you pretty much copy paste the content of the function, down below. Think of it like executing in one pass, line by line. So what this means in Vulkan is that we are not using any secondary command buffers. If we had secondary command buffers, there'd be kind of a parallel thing going, but this is all in one block inline. Okay, so we bind to the graphics, our pipeline, and we execute the draw command. This is the command buffer that is drawing, the vertex count, the instance count. We're not using instanced rendering in this case, so we just set that to 1. It's like the default instance. First vertex is 0, and first instance is 0 because we're not instancing. Then we end the render pass, and that's it. Then all we do is we end the command buffer, and we have stopped recording. Cool. Of course, down the bottom, we will need to destroy everything, and that is pretty much the standard routine which we've seen before. Now, a point here, command buffers are associated with the command pool, so destroying the command pool is sufficient to destroy all of the command buffers. So as you can see here, we've got it here. We're going to draw frame. That's the next video. I'm getting it ready right now. But it is non-trivial. Because Vulkan is multi-threaded, we have to deal with synchronization in our drawing commands. And yeah, it's a non-trivial thing. That'll be coming soon. Anyway, have fun, and I'll see you next time. Bye.